Welcome in my channel Digital World. Today we learn about Vlab and how to simulate digital circuits using Vlab. So click here in Google and type Vlab IIT Bombay. Click on first link IIT Bombay. Here are multiple labs are there. So select Digital Logic Design Lab. Then click on list of experiment. Today we learn about 4-bit comparator. So just click on implementation of 4-bit digital comparator using MSI ICs. So read the aim to design and implement 4-bit comparator using IC 74LS85. Click on theory. This is basic theory of 4-bit comparator. So this is the circuit diagram of 4-bit comparator. Whenever you want to draw comparator IC, first draw rectangle. There are two inputs are there. A, that is a 4-bit from A0 to A3. B is also 4-bit, B0 to B3. So here data inputs are there. Similarly, there are three outputs are there. A greater than B, A equal to B and A less than B. There are three cascading pins are there. A greater than B and A less than B. Both are connected to logic 0 or these are connected to ground. And A is equal to B. This pin is connected to VCC. So this is the circuit diagram of 4-bit comparator. This is IC that is of 7485. IC structure is given. Pin number 7 is pin number 8 is ground. Pin number 16 is VCC. There are inputs are there like A0, A1, A2, A3 and B0, B1, B2 and B3. There are few cascading pins are there, A less than B, A equal to B and A greater than B, and there are three output pins are there. So pin number 5, A greater than B, pin number 6, A equal to B, pin number 7, A less than B. So this is the truth table or functional table is there for comparison. This is the logic diagram of comparator. So this is the theoretical part of 4-bit comparator. Now click on pretest. There are few questions are given. Read the questions and click on correct answer. Then click on procedure. Here few steps are given how to verify 4-bit digital comparator. So first click on main switch. Then set appropriate inputs from A and B. After giving the inputs, observe the corresponding output and verify the truth table of 4-bit digital comparator. So in comparator there are two inputs, A of 4-bit and B is also of 4-bit. There are three outputs are there connected to 15 number, P15, P14 and P13. This is a small video to observe how 4-bit comparator works. So click on this tab and you have to run the video. The next one is click on simulation. See, in the simulation window, there are two inputs are given A and B. Respective pin numbers are given. So P6 to P9 are connected to input B and P12 to P15 are connected to input A. Similarly, there are three outputs are there. A greater than B is connected to P15. A is equal to B is connected to P14. A less than B is connected to P13. So P15 is A greater than B. P14 is A is equal to B. P13 is A less than B. This is main switch. So just click on first step is click on main switch. So VCC is on. Now this is 4-bit comparator. So P6, P7, P8 and P9. This is input B. P12, P13, P14 and P15. This is input A. Now here A and B both are 0. This condition is nothing but what? A is equal to B. So LED connected to P14 should be blue. The next one is click on P6, P7, P8 and P9. All LEDs are on, but in case of P12 to P15, all LEDs are, all inputs are off. So this condition is nothing but what? A less than B. because A is connected to 12 to 15 and B is connected to 6 to 9. Now the second case is click on 12, 13, 14, 15. This indicates that A and B both are equal. So LED connected to OP14 will be in on condition. So this indicates that A is equal to B. The last case, just check it. Make P6 to P9 0 and make P12, 13, 14, 15 in on condition. So A greater than B, this condition is satisfied. Now if you want to draw waveform, then you have to just click on capture for some time and then you have to click on stop capture. So as per our input, here we can say pin number 12 to 15 all are 1. So this indicates that 12, 13, 14 and 15 all are 1. P6 to P9 0. So this P6, P9, P7 and P9, P8 and P9 all 4 bits are 0. So what it indicates that in case of output OP15, this condition is for A greater than B. So A greater than B is equal to 1, A equal to B is equal to 0, A less than B is equal to 0. So if you want to check another condition, this 9, 8, 7 and 6 all are on. So click on capture for some time and then stop the condition. So this shows that 12 to 15 remains 1 but P6 to P9 1, 1, 1, 1 in the second transition. So this indicates that A is equal to B condition is satisfied. So P14, you can see here P14 is 1. This shows that A is equal to B, P15 is 0 and P13 is 0. In this way we can capture respective outputs. So just click on main switch, off it, then go back, then click on post test. There are few questions are given. Read the questions and tick the correct answers. Click on references. There are few references are given. Through those references we can get more about comparator. Last, click on feedback and try to share your experiences with virtual lab. So this is the way that we can use virtual laboratory to design and implement 4-bit comparator. Thank you so much.